Hello everyone, this is another video based on the prefix sum and hashing pattern. Some problems I have already discussed in my previous videos, which you can check them inside the I button or also inside the description. This video I am going to explain two other problems which are closely related to each other. One is the longest subarray with equal zeros and equal ones, and another problem is to count all those subarrays which contains equal zeros and equal ones. So first of all, let's get into this particular problem. The problem statement says is that we are given with a binary array nums consisting only of the zeros and ones, and a subarray is a contiguous part of the array. Our task is to find the length of the longest subarray that contains an equal number of zeros and ones. And if no such subarray exists, then we have to return 0 in this case. So the problem statement is simple. The binary array is given, which means the array contains only zeros and ones, and there will be multiple subarrays in the input array, which will be having the equal zeros and ones, but we have to find the length of the longest subarray which is having equal zeros and ones, and if no such subarray exists, then we have to return 0 in that case. This is the problem, and now let's get started with the approaches which we can use in order to solve this particular problem. First of all, very simple approach which we can think of, a kind of naive solution, to try out all the possible subarrays, and for every subarray we will be checking for the equal zeros and equal ones. So basically we will be counting the zeros and ones, and if any subarray is encountered having equal zeros and ones, then we will just take its length into consideration and just compare it with the previous subarray length, if it is greater or not. So if it is greater, then we will just take that inside the result. This is the simplest approach, and along with this, it is also slower and less efficient because basically use the two loops in order to solve this, because trying out all the possible subarrays is less efficient. The time complexity goes to big O of n square, and for this we will have to move towards a better approach. So the implementation part of the brute force is very simple, and just to use the two loops and count the number of zeros and ones. Any time when we get a subarray with equal zeros and ones, we can just update its length. Now, before moving to the another approach, firstly I would like to take a simple example, and with that simple example, I will just make some of the observations. Okay, so this is the example which I have taken, and now I am going to build some of the observations on this example. I am saying that I have to have the subarray which is having equal zeros and equal ones. So if the array is having equal zeros and equal ones, then for sure the difference between their counts will be 0. So I am saying that whatever the count of 0 is there, the count of zeros and the count of ones, if I take the difference of both, that will be 0. This is one thing. And now I am saying that what if I try to convert this particular array into um, a form where I will be converting every 0 to -1 and every 1 will remain as it is, like +1. So the array will be converted into minus ones and ones. Now I am saying that whatever the subarray will be there, which is having minus ones and ones. Now if I try to take the sum of that particular subarray, that will be representing the difference between the count of zeros and count of ones. So now I am trying to convert this particular problem into a simpler problem. Now what I am trying to say is that if I want the difference of count of ones and count of zeros to be 0, I am saying that a subarray contains which contains minus ones and ones represent this particular difference. Then for this to be 0, for the difference between count of ones and count of zeros to be 0, I can say I can find a subarray which is having the 0 sum. And another thing, if I want the longest subarray which is having the equal zeros and equal ones, then only their difference will be 0. If I want the longest subarray with equal ones and equal zeros, I can say that I can find the longest subarray which is having the 0 sum. So therefore now the problem is not about to count the or having the length of the longest subarray which is having equal zeros and equal ones. Now the problem is converted to a simple problem which we have already solved earlier in the previous videos, that is finding the length of the longest subarray which is having 0 sum. So now what I have just built the two observations. One is that if I am having a subarray with equal zeros and equal ones, for sure the difference between their counts of zeros and ones is going to be 0. And I have mapped this particular situation to another situation, that if I am having a subarray of minus ones and ones, then the sum of that particular subarray will represent this difference. And for this difference to be 0, that subarray sum must be 0. So that's all about the observation. And now we have to find for the length of the longest subarray which is having the subarray sum 0. And for that, whenever I get a particular 0 in this input array, I will be taking it as -1, and 1 will remain as it is, and therefore my array will be converted into minus ones and ones. So just remember, I am not converting this particular array into a different array, or I am not going to uh, use any extra array in order to do this. Whenever I will get a 0, I will just convert it into -1. Okay, so I have just taken a simple visual here just to make you understand. Whenever I'm seeing a 0 inside the array, I will be taking it as -1. And I'm not going to use any extra array, or like I'm not going to change the original array or the input array. I'm just saying that whenever I see a 0, I will be converting it explicitly into -1. Like whatever the element I have taken, I will be taking it as -1, and 1 will be as it is. This is the same array itself. I am just not finding the length of the longest array with equal zeros and equal ones. Now I am going to find for the length of the longest subarray, which is giving me the sum 0, and that the result of that particular problem will be the result of my actual problem. So now let's get into that problem which we are going to solve for the previous problem. Here I have just converted all the zeros to like -1s, just to make you understand for now. These are the -1s and ones array. And now, as I have told, that there will be multiple subarrays with that particular sum 0. Like this -1 and 1, this is giving me a subarray sum 0. This 1 and -1 is giving this -1, 1 0 is giving this particular length 4 is giving. But I want the longest one. So here we can see that this is the longest array, which is having the subarray sum 0. 3 ones and 3 -1s are there, which balances out, cancels out the things, and the result to 0. This is a particular array which will be having as a result as the length, the longest length of the subarray. And just like this is just a kind of understanding. Whenever we get a particular subarray with the sum 0, and that is also the longest, why it is giving the sum 0? Because it contains equal number of ones and equal number of -1s, and because we have converted every 0 to -1 and 1 to +1, because of that mapping, we can directly say that yes, this is the length of the longest subarray, which is having equal zeros and equal ones, because this is nothing but the mapping from 0 to -1 and 1 to +1, where we can see that it contains of equal zeros and equal ones. So this is all about this intuition, or we can say the observation to make in order to solve this problem. Now let's get into the example which I have taken here, and let's perform a dry run on this. Okay, so this is the example which I have taken in order to perform a dry run. Now, what we have to do is, because we have converted our problem into the simple problem in order to find the length of the longest subarray, which is having zero sum, that we have already solved in the problem where we have found the longest subarray with the sum k. Here, just to make you understand, I'm just taking every zero as -1. That we will not be doing in that way, because in implementation, whenever we have the 0, we will just take it as -1. That in that way we will be solving. That we will see in the implementation part. But for now, for the understanding, let me just convert all the zeros to -1. This 0 is also minus. This 0 is also minus. Also minus. Now this particular problem we have to solve for finding the length of the longest subarray with zero sum. What approach we have to use, that we have already saw in previous videos, where whenever we have to get the length of the longest subarray with a particular subarray sum k, and also we have checked for k equal to 0, what we have to do is we have to get a prefix sum or a cumulative sum at every index. Prefix sum is like we accumulate the sum from the previous indexes till the current index. And whenever we have a prefix sum, we basically check for the same prefix sum if it was encountered earlier. Okay, so from that particular index where the prefix sum was available earlier, from that index +1 till this current index is a subarray which is having the sum 0, and that's what we need. We have to check for the subarrays with the sum 0, and whenever we get a subarray with sum 0, we will just take its length into consideration and update based on the previous length if it is maximum. So that's what we have to do. And now let's just perform a dry run. And for this, what we have to do, we have to basically store the prefix sums in order to check if it was encountered earlier or not. And along with that, we will also have to check for the index. Based on the index, we will be calculating the length. So for that, I will be using the unordered map here, the unordered map, and let's just name it as map. This is unordered map, and here I will have to maintain a prefix sum. This is a prefix sum which I have taken for now, and I will also be taking the length variable to take the length. Now first of all, I will be pointing at 0th. Now I is at 0th x, and now firstly -1 will be encountered, so -1 coming and added inside the prefix sum. This will now become -1, and now we have to check -1 in the map if it was available or not. So -1 is not present inside the map, and then we will just take that -1 and update it inside the map along with the index. So at 0 index we have the prefix sum -1. Then I will be moving ahead. When I moves ahead, it will again see a -1, and then it is like it sees a 0 and then it takes as -1. Now -1 comes and then will be added inside this, and this becomes -2. Now for -2, again we will check inside the map. -2 is not available, so -2 will come inside the map along with its index. So at one index we have seen the prefix sum -2. Now I moves ahead and it sees a 1. So to do anything, just add inside the prefix sum and it will become -1. Now, is this -1 available inside the map earlier? So yes, -1 has been encountered at 0 index. At this particular 0 index, the prefix sum was -1. It means the current index, we are at this second index right now. From that 0 index where -1 was available, from that after that 0 index means from 1 to second index, this subarray sum is having the sum 0. And therefore, we can say that if this subarray sum is having 0 sum, therefore, the difference between the count of zeros and count of ones will be 0, because we can see here equal -1 and 1 are there. Therefore, equal zeros and equal ones will also be there. This is a subarray which is having equal 0 and equal 1. So this is the kind of mapping with that problem. Okay, so now let's get into this approach. Here we have seen a subarray with the sum 0, and now we will have to take its length. How we take the length? At whatever current index we are now, and whatever the index where this prefix sum was available earlier is at 0 index, we just have to subtract these, like I this 2 minus 0, that will be giving the length for this subarray. And the maximum out of 0 and 2 is 2, so we will just update this max length by 2. And now do we have to update this particular prefix sum inside the map with the index, because this prefix sum is also -1, and we will have to basically add inside the map or not, that we have to check. Now, we have also seen in the previous problems, whenever we find the longest length, or the length of the longest subarray, then we need not to update the index for the same prefix sum, because if we are going to do that, if we are going to re-update the index for the same prefix sum, if it got repeated, then updating with the latest index uh, means we will not be getting the longest subarray, the length of the longest subarray. If this particular -1 was again encountered, or like whenever we move forward in this array, and again we will have to check for -1, it will not be giving this minus in this 0 index, because at 0 index -1 was also the prefix sum, and it got again repeated at second index. When in future we are trying to check for -1 again, and it will be giving this second index, not the 0th index. Therefore, the longest subarray will not come in that. We need not to re-update this prefix sum if it got repeated again. Thing we have seen, and now we have also updated the max length. Now I moves ahead and it's again a 0, so it will be taken as -1. Now the prefix sum will be updated by -2. -1 is added, so it will now become -2. Now -2 is also available inside the map, and that was at index 1. But this particular index 1, -2 was there. Till this index, the prefix sum is -2. Now for this, after this one index means 2 to 3, it is again having a subarray sum. Here we will again check for the length, and the length will be 3 minus 1, because at one index that -2 prefix sum was available. 3 minus 1, that will be, and max of 2 and 2 is 2 only, so max will be remaining. Do we have to update this -2 here with the latest index? No, because it will not be giving us the maximum length or the longest length if it was encountered again in the future. So we need not to update this. Now I moves ahead and it again sees a 0, that will be taken as -1, and now this fixed sum will become -2 minus 1, that will be -3. And now -3 is not available inside the map, so -3 will be updated with its index, that will be fourth index. Then I moves again ahead and again a 0, that will be, now it will be -4. In -4 is not available inside the map, so -4 will be updated inside map along with the index, that is 5. Then I moves again ahead and the 1, therefore the prefix sum is updated to -3. And because this -3 has been seen inside the map at fourth index, so till this fourth index, this particular subarray is giving the sum prefix sum -3. This subarray -4 plus 1 -3. Till this fourth index it was -3, so therefore from this 5 to 6 index will be subarray with sum 0. So this is again a subarray sum 0, so the length will again be taken, that is 6 current index minus the prefix sum where it was encountered earlier, that was fourth index, so 6 minus 4 will be again 2. The max length will be remaining 2 as this case as well. Now -3, we need not to update it, and again this I will move ahead and it the 1, therefore it becomes -2. And now again the prefix sum is -2, so it will again check inside the map, and 2 -2 was available at one index at here. Okay, -2 was available at this, -2 was available at this till one index, 2 to 1. Therefore from the second index till this current index 7, this is the subarray which is giving me the subarray sum 0. There we can see 3 ones are there, and 3 minus ones are there, so therefore they cancels out and just resulted to 0 sum. This is another subarray, and now we see the length. Current index is 7, and the last time where -2 was present, that was at one index. 7 minus 1 will be giving the length, that is 6. So maximum out of this 2 and 6 is 6, so the max length will be having this. And now this the prefix sum -2, so not to update this. Now I moves ahead and the loop gets ended. So max length is updated with the value 6. So 6 is the length of the longest subarray which is having the 0 sum. And because we said that this particular problem means subarray with the sum 0, it basically represents the count of the difference between the count of ones and zeros. So if we got a length of the longest subarray, this is giving me the subarray sum 0. Therefore, we can say this is the length of the longest subarray which is having the equal zeros and equal ones. Because if this subarray sum is having 0, then it is having equal minus ones and equal ones. And because we have mapped -1 from 0 and 1 to 1 from +1 to from 1, therefore this particular subarray is having equal zeros and equal ones directly, and that this 6 is the length of that particular problem which we are solving. Now this particular array is not having that case where the subarrays will be starting from the 0th index, otherwise we will also have to insert that one case with 0 and the index -1. If any subarray will be existing and which is starting from the 0th index, then this particular case also has to be here. So this is all about the logic and the dry run. Now let's get into the implementation part and implement this. So this is the function which we have to complete. Firstly, I will be taking the size of nums here. Nums for size. And now I will be taking the unordered map. And in this unordered map, we will have the two parameters. One is the prefix sum and another is the index where it came. Let me just set it as empty. And now, as I have told, one case for the subarrays which will be starting from 0 index. For that, we will have to take the 0 along with its minus. That I have already explained. That's why we have to. Now, I will be taking the prefix sum in order to get the prefix sum at every index. Also, variable initializing it with. Later on, whenever I get the length of the subarray which is maximum, I will just update it inside the max length variable. Now let's write the loop in order to traverse this entire array, and I equal to I less than n I plus plus. And firstly, I will be taking the prefix sum. Okay, what we have to do here is whenever we see a 0, the input array, we have to take it as -1. That is explicit. So if I see this nums of I as 0, then I will be just taking that as -1 at the nums of I. Here I'm not going to change the array, or here I'm not going extra array. I'm just taking it explicitly. Whenever I see a 0, I will take it as -1. Then I will be using. So then I will just take this prefix sum and add it with this nums of I inside that prefix. Now I will have to keep a check. What we do in the case of subarray sum 0, whenever we get a particular prefix sum, we check for the same prefix sum if it was encountered earlier, and then it got repeated now. So therefore, that particular index where it got repeated or it was available, then from that index +1 till this current index is the subarray sum 0. Firstly, inside the map, I will just check using the find function that if this prefix sum was available or not. That is using this particular condition. Dot end. if that particular uh, prefix sum was available, then it will be the iterator will not be pointing at the end position, pointing at some other position will not be, which will not be equal to end. The condition is true, and then I will just take this length of that subarray. So max of the previous max length which I was having, and current length which I have to find, that is the current index I minus the last value. How I will be taking, let's say I have to take this particular 4, map of this key, map of -3. That's how I have to take map of the prefix sum. That will be giving me the index or the second parameter. Right? This is how I have taken the length. Now we will have to firstly check whenever we are inserting this of the prefix sum inside the map. Firstly, we will have to check if it's available or not. And if it is getting repeated, then we cannot update it with the latest index. Otherwise, it will not be giving us the length of the longest or the longest subarray if it is going to encounter in the future. Therefore, we will have to firstly check if it is available inside the map or not. If it is not available, then only we will be updating inside the map with the index. So firstly, I will be checking inside the map and function find that prefix sum this index condition. What this is doing, if any prefix sum is not available inside the map, and that position the iterator will be pointing at end position, that will be equal to end. Condition is going to true, and we just have to then go inside the map. For that prefix sum, we have to update that index I. This is what we have to do, and then at the return this. Let me just the input. The input is 001, size is 8, 001, 00011, 000, run it now. This is the length of the longest subarray with equal zeros and equal ones. This particular length, particular subarray means 3 ones are there, 3 zeros are there. So this is the length of the longest subarray. Okay, so now let's check the time complexity and space complexity. Here we are using this loop in order to traverse this entire array, and for every element, because we are using the unordered map, so for every element the like find operation, insert operation, these are taking the constant time. So therefore the time complexity goes to big O of n. And now talking about the space complexity, so again if there are the distinct prefix sums, then in that case they will be going separate, like the distinct values inside the map. Therefore the in the worst case the space complexity will go of n. This is what we have seen in this problem. Now another problem is related to this particular problem. We have to now count the subarrays, all those subarrays which are having equal zeros and equal ones. This is the problem statement. And here we are given a binary array nums consisting of zeros and ones that we already know. Array is a contiguous part of the array. We have to count the total number of subarrays that contain equal number of zeros and equal number of ones. And at the end, we have to just return the count. So the problem is simple. We are given with the array which is having zeros and ones. And now this time, whatever the subarrays we are getting with zeros and ones, we have to now count those subarrays. And we have to then return the count of that. So again, if we see the very simple approach or the brute force approach, then it is again trying out all the possible subarrays, and for every particular subarray you will have to count the zeros and ones, and if the subarray is having equal zeros and equal ones, we will take its length into consideration and update it based on the maximum length. So this is going to be very simple implementation for this, just using the two loop. uh, as the as we see the different subarrays, all the possible subarrays, we just take the count of the zeros and ones and just match it if it is equal or not, the zeros and ones. Let's just see its implementation for the brute force as well. The function which is right, very simple. First of all, I will be taking the length of this size. uh, this I will just have to obtain the count in order to count the subarrays. Now I will be just using the to loop for int I equal to I less than n, I plus plus, then another loop in order to have the all the possible subarrays starting from I. This particular logic I have already explained. The problem where I have solved the length of the longest subarray with subarray sum key. That was the very first problem that I will also add inside the description. And here I have explained how the all the possible subarrays are. This g less than n, g plus plus. Now what I have to do is, for every particular index from where this subarrays, we have to check all the possible subarrays. So let's say we are at 0th index. For that we will be firstly checking for the 0 index only. Then from 0 to 1, as this j increments, then second subarray comes. Then when j increments, again third subarray, and j increments, again fourth subarray. So likewise for every subarray we will be checking for the zeros and ones. So whenever I come at 0th index, and then I have to try out all the possible subarrays, firstly I will be taking the count of zeros. So I am now initializing this count of 0 as 0, count of 0 as 0, and second is the count of ones. Count of 1 is also, I'm now initializing it with 0. Now when I am starting with the subarrays, first of all this I is 0 and j is 0. Basically I am checking for a subarray from 0 to 0. Then j increments, so from 0 to 1. Then j increments to 2, 0 to 2. Likewise all the possible subarrays. So first of all I will be just making a check if this nums of j equal to 0. If it is equal to 0, then I will be just increment the count of 0, or else this is going to be 1. So I will just increment the count of 1. This is how I will get the count of zeros and count of ones for that particular subarray. And then I will be checking if this count of 2 minus count of 1 equal to 0 or not. It's just the case which I have explained in my in just a previous problem. Here itself, that the difference between the count of zeros and count of ones is 0 whenever they are equal. So if this is equal, then I can just implement this count, the count variable which I have maintained for this number of subarrays. So whenever I get this particular situation or this condition true, that the count for any subarray for zeros and ones, that their difference is 0, and I can just increase the count because I have got a one subarray. At the end I can just return this. Let's just 5 subarrays are there with equal zeros and equal ones. One is the subarray. It's the same thing. When we have to count the subarrays as well, we will have to basically convert every 0 to -1 and 1 to +1. And this is how we are saying that if any of the subarray there is having the sum 0, means after converting in -1s and 1s, whenever we are getting a subarray with some 0, that is basically representing the difference between the count of ones and count of 0. Okay, so whenever we get a subarray with some 0, that will be counted as the subarray with equal zeros and equal ones. This is, here we can see that this 0 1 1 0 1 1 is there, this case as well, and case as well, and this particular subarray is also there, like 0 1 0. The one subarray is the entire array. In we can also check from here, subarray sum is subarray is subarray is having 0 particular array of length, entire array, 1 and 3. What it basically represents is whenever the subarray sum is 0, means we are having the difference of count of ones and count of zeros as 0. This is the brute force approach, but again this is using the two loops. Okay, and in this particular thing, it becomes less efficient and leads to n squared O of n squared time complex. So we will have to obviously go towards a particular better approach. For that better approach, we have also seen in the previous problems as well, like whenever we have to count for the subarrays for a particular condition, then we can use the unordered map. In that case, again the prefix sum and the hashing approach. So let's just perform a dry run on this. Now this is the example on which we have to perform the dry run. So again, what we have to do is, now again we will be converting this problem into a problem where we will be finding the subarrays with zero sum. We will not be checking directly for the equal zeros and equal ones. We will be checking for the subarrays having the zero sum, because if the subarray is having zero sum, it basically represents a subarray with equal number of zeros and equal number of ones. The difference between their counts will be 0. So already we have seen for such problems where we have to count for something inside the array based on some conditions. So here we have to find the number of subarrays which are having zero sum. So again we will be using the same approach, the prefix sum and the hashing approach, in which the unordered map, where we will have to take the unordered map in order to store the prefix sum along with their frequencies, that how many times the prefix sum came in the past. The number of time it came in past, that number of subarrays will be which will be ending at that current index which we are at right now. So in this, firstly let me take the unordered map here. Let me just as frequency map, because we will be frequencies of the prefix sum. This is the frequency map, and in let me just maintain the prefix sum here to have the sum every index. This is the prefix sum, and so I will be maintaining count and not count the subarrays. And this is, I will be first pointing at 0 index. Now again, it's when it sees a -1, so we have to take it as, so okay, sorry. Whenever this I pointer sees a 0, it will be considering it as -1. So let me just convert all these. I is now pointing at 0th index, and it will see a 0 which will be taken as -1, and -1 will now be added inside the prefix, become -1. Now it will now we will see inside the map, and -1 will not be available inside the map, so we will have to just insert that inside the map along with its frequency count. -1 is available, and that was one time as of now. So prefix sum -1 is one time, seen one time as of now. And now I will move ahead and it will again see a 0 which will be taken as -1, and again this particular sum will prefix sum which will become -2. Now we will check inside the map for -2, and -2 will not be available, so we will be again updating this -2 with count for 1. Now I moves again ahead and it sees a 1, just add inside the prefix sum which will now become -1. -1 will be seen inside the frequency map, so -1 is available one time, that was at the 0th index. 1 is available at the 0th index. So we can also see inside the array that from at if this -1 was available at 0th index, there is one subarray which is 1 to 2 index. And also whenever we are having the frequency map and we are seeing for the second parameter for the frequency, so the number of times that prefix sum was encountered earlier in the past, that number of subarrays will be formed which will be ending at this particular index. And as it was repeated second time, so therefore from that last index where it was encountered, like at 0th index, sorry, from this 1 to 2 index, one subarray is there. So therefore we have to just update this second value, the second parameter, that -1 was encountered once, so therefore one subarray will be there which will be at this current index. Therefore we will be just updating that inside the count, and this count will become 1 now. But now this prefix sum is -1, so do we have to update it inside the map or not? Now here we are not finding for any longest subarray or something else. We are just having the count of the prefix sums, which is the core part of this. That we have to count the frequency, the number of times that prefix sum encountered, that number of subarrays will be formed, which will be ending at that current index. So this is the core part. Whenever we get a repeated prefix sum, we must update it inside the map so that we can get a count that how many number of times it came in past. So if this subarray, if this prefix sum is -1, we will have to update it inside the map. Now for this -1, because it takes the unique values, the map takes the unique values, it just updates the frequency or the second value. So because it came now second time, so when we updated it second time, it will become from 1 to 2. So this is the prefix sum -1 updated inside the map. Now I will move ahead. I will move ahead and it will see a -1. Again, it will be added inside the prefix sum and it will now become -2. So now -2 is available inside the map or not? So yes, -2 is available, and that was one time till now, which we have seen at that one index. You can see inside the array. Map will only tell that how many number of times that prefix sum came. But from the array, we can just see here that -2 was available at one index. And after that, from 2 to third index, this subarray sum is giving the 0. And also this map is telling that -2 was available only one time till now. So therefore, second value will be updated inside the count. Now it will become 2. So till now we have seen this particularly in this input array, the two subarrays are there which are having 0 sum. It means the subarrays which will be having equal zeros and equal ones. Now this -2 is there. Now we will also have to update its count inside the map. So this count will be incremented to 2. Now I moves ahead and it will a 1. So now added it will become. Now have we seen this minus 1 before? Yes, we have seen minus 1 before, and that also 2 times. This map is only telling that it was encountered 2 times. The array also we can see that minus 1 was available one time at this 0th index, then second time at this second index. Minus 1 was here, and after that it also carried till second index. That's how it was seen to count will be incremented by become 4. 4 subarrays till now. Again, okay, so for this prefix sum, we will also have to update inside the frequency. Again, this I moves ahead and it will again see a 1. Now this particular prefix sum becomes 0. But have we any record for the 0 inside the map? No. Again, that same case comes. Initially, when we have not started with the prefix sum or the cumulative sum, at that point, this prefix sum was 0. It is a kind of virtual prefix sum. Also, because nothing was there, only one time was there, so we can press count 1. But initially, prefix sum was 0 one time. So now we are saying that is this prefix sum 0 was encountered earlier? So yes, it was encountered earlier when we have not started taking the sum from the 0th index, and that was only once at that point. Therefore, you will be inserting that initially inside the frequency with one count that we have to do at the start itself, because that is a kind of a case of NH keys in order to have the subarrays, the valid subarrays which are starting from the 0th index. Now, have we seen this 0 inside the maps? Yes, and that was one time. So there will be inside the count 5. Then I moves ahead and the process gets stopped. Here we can see that we are having this count as 5. Is the 5 subarrays are there in this input array which are having the subarray sum 0, and that represents the difference between the count of ones and zeros. So therefore, the subarray sum 0 is the subarray with the equal zeros and equal ones. We are having a subarrays, the number 5 subarrays with equal zeros and equal ones. Therefore, we can say directly that we are having the subarrays with equal ones and equal zeros. That number of subarrays are 5. So this is the simple approach and the logic which we have seen. Now let's again get into the implementation of this hashing approach. So let me just remove this. Now what we have to do is I can just take the unordered map here. Third map have the two parameters, one for the prefix sum and another one for the frequency. Let me just test frequency. At the start, we will have to take the frequency of 0 as 1, not started taking. So now I will just take the prefix sum variable, starting with, and also I will have to take the count of this subarrays at the end, which I have to return. So initially started with. Now I will be just running a loop for auto and every value from the nums array, and now see again I will be putting a check here. If any of the value, if that particular value which I have taken, if it is equal to 0, then I will be taking that value as -1. If that value is 0, I will be taking it as -1, and then I will be moving with the further process. Here the prefix sum I will be taking prefix sum equal to prefix plus well the num sorry which I after this I will just check inside the map, inside the frequency, the find function, the same prefix sum was available earlier or not. Condition dot end. So if this prefix sum was encountered in the map, then I will be taking its second value or the second parameter. Like this case, what we did, if the 0 was encountered inside the map, yes, this encountered, and then we will have to take the second parameter. Because if it was encountered and it will be present some number of times in the past, that number of times or that number of subarrays will be there which will be formed at and ending at this current index where I am right now. That second parameter, the second value I will have to fetch from there. Count plus equal to, like count equal to count plus frequency of that prefix inside the map, that I will take. And now I need not to check any prefix sum is available or not. I just have to have the count of that prefix sum, that how many number of times it came. Even if there is a repeated prefix sum, I will have to take the count of it, so that later whenever it is checked inside the map, I can get to know that how many number of times it was available in the past. I can just take count of that inside the frequency of that prefix. I will just end return the count, the subarray. I will just take 201 to 11 is 201 to 11. Five subarrays are there with equal zeros, equal ones. This is the whole problem. And now again for the time complexity, this loop is running for one time where it will be element. And again inside the unordered map, every element for the find and the search operation, constant operation. So O of n time complexity. Just in case if the collisions occur, then in that case it might go to big O of n square. And for the space complexity, again if there are the distinct prefixes, then in that case, in the worst case, they will be going inside the unordered map individual value for the space complexity will O of n in there. This is all about this problem, and for the more problems, I will be coming with another video.